Hello everyone and welcome back to Dr. Saurabh Sir's classes. Today we are going to solve a very important and conceptual problem from heat transfer fields, and this type of question is extremely common in the examinations. Now the question is, an infinitely long fin of square cross section is replaced by an infinitely long fin of circular cross section. All the thermophysical properties remain constant and the side of the square fin is equal to the diameter of the circular fin. Now we need to find the ratio of heat transfer before and after replacement, and the options are: option number A is 4 by pi, option number B is 16 by pi, option number C is 16 by pi square, and option number D is 4 by pi square. Now first, let us recall the formula for the heat transfer from an infinitely long fin. Okay. For an infinite fin, we can say Q is equal to root over of HPKA into TB minus T infinity. Okay. Now where H will be the heat transfer coefficient, P is the parameter of the cross section, K is the thermal conductivity, A is the cross sectional area, and TB minus T infinity is temperature difference. Okay. Now the question clearly says all thermophysical properties remain constant. That means H is constant, K is constant, temperature difference is constant. Okay. So when we compare the heat transfer rates, all these terms cancel. So we can write Q versus root over of P into A. Okay. Now this is the most important idea in this entire problem. Now let us assume side of square is A. And given in the question, side of square is the diameter of the circular fin. So we take both equal to A. Now for the square cross section, area A1 is small a square and perimeter P1 is 4 small a. Okay. Now multiply P1 into A1. So we get 4a into a square, that is 4a cube. Therefore, Q1 versus root over of 4a cube. Now consider the circular fin. So diameter is small a. So radius will be what? Radius will be a by 2. Now the area of the circle A2 is pi r square. That is equal to pi into a by 2 whole square, that is pi a square by 4. Now the perimeter P2 is what? Pi into d. Okay. Now multiply. So we get P2 into A2 is equal to pi a into pi a square by 4. Okay. So this is equal to pi square a cube by 4. So we can say Q2 versus root over of pi square a cube by 4. Now taking the ratio, we need Q1 by Q2. So Q1 by Q2 is equal to root over of 4a cube by root over of pi square a cube by 4. Now combine inside a single square root. So we get root over of 4a cube by pi square a cube by 4. Now dividing by a fraction means multiplying by its reciprocal. So we get root over of 4a cube into 4 by pi square a cube. Now cancel a cube, so we get root over of 16 by pi square. Now take the square root, so we get 4 by pi. So the correct answer is 4 by pi. Let's check the options. Option number A. Okay, so option A will be the right answer for this particular question. Now, let us understand what this means physically. Since q square by q circle is 4 by pi, and we know 4 by pi is near about 1.27, right? That means the square fin transfers about 27% more heat than the circular fin when side of square is equal to diameter of circle. Why? Because the square cross section provides a better combination of the perimeter and the area for the same characteristics dimension. Now remember, for infinite fins, heat transfer depends on root over of P into A. Okay, so both perimeter and the area matter simultaneously. Now students often make one big mistake. They compare only area or they compare only perimeter. This is wrong. For the finite fin, Q varies as root over of P into A. Both must be considered together. And also remember, infinite fin is tip temperature assumed equal to ambient, and that simplifies the solution, and this is why formula becomes neat. So whenever you see infinitely long fin, all properties constant, compare heat transfer, immediate apply this method. Okay, so heat transfer ratio square by circular is 4 by pi, so correct answer will be option number A. This is a beautiful example of how geometry influences heat transfer performance. Okay, so this was the whole solution for this question. See you in the next video with a new question. Till then, bye bye.